so in this part of the chapter, we will talk about the types of IP address version 4. There are two major types of IP addresses. We have private IP addresses and public IP addresses. The private IP addresses are the addresses that can be used within a local area network, and it cannot set as a destination address in a packet in the WAN. So the private IP address has significance only in the local area network beyond the router, but actually this router will have to change this IP address before it forwards the packet to the public internet. So the service provider cannot forward a packet with a private IP address. And that's a way for us to reuse these private IP addresses within our home networks. And that's why in our home networks, we always have an address which is 192.168. something, if we notice. And all our homes, they use this IP address, even though the IP address has to be unique. And in that case, if this IP address is forwarded to the service provider, this router, our home network or our home router, will have to change that private IP address into public IP address. So the range of private IP addresses are highlighted here. So we have 10.0.0.0/8, which means that any range of 10 dots anything is a private IP address. And then 172.16.anything is also an IP address. And 192.168.anything is also an IP address. So those three categories or those three ranges of IP addresses can be reused within any network, and if a router happens to forward these packets, it has to change this private IP address to a public IP address before it forwards the packet further. So this exercise, for example, gets us familiar with the private IP addresses and public IP addresses. So if the packet uses a private IP, then this service provider router should not forward the packet to the public internet. So in few seconds, we need to recognize whether the incoming packet has a public IP address or a private IP address. So let's try to do that. So let's start. So this is a private IP address. So in that case, we should actually block it, and in that case, we subtract it. So this one is actually also a private IP address. Also, this is wrong. So we have, so this is okay. So this is a public IP address. So we pass this. So we have to do that very fast. And this is a public IP address, so we can pass it. So that's also a public IP address, so we can pass it, and so on. So if the answer is correct, then you get a +1. This one is okay, it's public. I'm waiting for a private one now. This one is public. Remember, it's 172.16. This one is private, so we have to block it. All right, so that's correct, and so on. So that's also a private one, which we have to block it. All right, so that's how we calculate that. There are some, in addition to private and public IP addresses, there are some special IP addresses that has some special handling. These special IP addresses are not forwarded beyond the LAN router, not the service provider router in that case. And each one of these special IP addresses has a different meaning. So, for example, we have, the first one is what we call a loopback address. As we have learned before, the loopback address is used to ping or to send a packet from a host to itself. And this is a way for the host to verify whether the TCP/IP stack is actually working or not. So the loopback address is used to send from a host to itself. There is another special category of addresses, which is what we call link local addresses. So the link local addresses is a class of or a range of IP address that starts from 169.254 dot anything. So anything in that range is called a link local address. So the link local address is a special class of IP addresses which is set dynamically by the operating system. So if the operating system tries to connect to the DHCP server and it cannot connect to the DHCP server, so in that case it cannot obtain a dynamic IP address. So in that case it sets the IP address on the host randomly or arbitrarily using this class or this range of addresses. So the link local address, it cannot be used as a host address to communicate over the internet, because the local router will actually suppress or will stop any packet to these addresses. So if the host has this address, it can communicate within the LAN, but it cannot communicate through the internet. And it's basically when you try to connect to the DHCP server and the DHCP server is down. In that case, the operating system itself will set this address for you. Another class of addresses, which is what we call testnet addresses, and these are addresses that are used only for testing and learning, and these are used for documentation. So the standards, they actually use these IP addresses for documentation. And in that case, if it happens that we set the local host address to one address in this range, again the router will suppress this packet and will not forward it to the public internet. The last class of special IP addresses is what we call experimental addresses, and these are in this range from 240 to .0.0.0 all the way to 255.255.255.254. This range of IP addresses cannot also be used as a host address, and it's actually reserved for future use, although in some cases this range of IP addresses can be used for host address, but based on certain conditions. Historically, IP address version 4 has gone through some changes. So at the beginning it started with what we call classful IP addressing. So for classful IP addressing, the subnet mask can change from /28, as we can see here, all the way to /32. So class A talks about a range of IP addresses that has a subnet mask or a prefix length of /8. So if you have a prefix length of /8, this gives you, as we all know, /8, this means that we have 8 bits for network and 24 bits for host, so that gives you 2 to the power 24 different host addresses. So that gives you around 60 million different IP addresses. And if you use a subnet mask of /9, then you end up with this number and so on. So class A talks about the range of IP addresses that has /8 subnet prefix, and class B talks about /16, and class C talks about a range of IP addresses that use /24. So at the beginning, the internet started with started with more than 3 classes: class A, class B, class C, and there's class D as well for multicast, which is not mentioned here. Class A gives the service provider the ability to assign addresses of size 60 million, and class B allows the service provider to assign addresses of /16, which is around 65,000 IP addresses, and class C gives only 8 bits for host, so that gives you around 254 host addresses only, and that's used only for small networks. So class A here ranges from 1 to 127, or from 0 to 127. So if you find the numbers that starts from 0 all the way to 127, you will find that they all start from 0 and then something. So 0 and 0 all the way to 7 months. So this is actually 127 and this is 0. So anything that has 0 and something is actually class A. And class A means that the subnet mask is actually /8, which means that you have 8 bits for network and 24 bits for host. Class B is the second range, and it always starts from 1 and then 0. And then anything else. So that's 1 and then all zeros. This is 128, and 10111111. That's actually 191. So that's the range of the class that actually has subnet mask of /16, which means that you have 16 bits for network and 16 bits for host. Class C starts from 192 all the way to 223. That's 192 is actually 11 and then all zeros. 110 and anything. And if you put all zeros here, you will end up with 192. If you put 11 and then 0 and then 6 ones, so that's actually 223. So for this range of IP addresses, the subnet mask will be /24, which leaves 24 bits for network and only 8 bits for host. Class D is reserved for multicast, and it ranges from 224 all the way to 239, and then class E is used only for experimental purposes, which starts from 240 all the way to 255. So the class D and class E, they do not use special subnet mask in that case. So only A, B, and C, they use special subnet mask. So again, A uses a subnet mask or a prefix length of /8. B uses /16, and C uses /24. Okay. So these coarse type of categorization for classes for IP addressing has created a shortage of IP address, because if you have few networks, only 27 networks, with each one has more than 16 million IP addresses, and you have some networks like the B class, each one that has 65,000 and so on. So if you categorize these IP addresses in classes, that actually creates some kind of coarse categorization of IP addresses, and that actually caused some problems for IP address assignment at the beginning when the internet first started, and later on they developed the concept of subnets, as we will learn in the next chapter. So of course, the network part is assigned by an international organization called DIANA, or International Assignment of Network Addressing, and then each host will, or each network will assign the host IP address that corresponds to each host. Of course, we talked about the service provider architecture for the internet. So you have tier 1 service providers that typically in the past they used to use class A address, which gives tier 1 service provider the ability to assign IP addresses to many tier 2 service providers, and then tier 2 service providers will then typically use class B IP addresses, which gives each network in the tier 2 service provider the ability to assign around 65,000 IP addresses, and then tier 3, which might use class C. And of course, later on, the classical IP addressing have been cancelled or have been revoked, and then we use the concept of subnet mask to represent a more fine-grained categorization of IP addresses, as we will learn in the next chapter. So that exercise here, again, gives us the understanding, or gives us the ability to categorize public and private IP addresses. So 172.16, this is actually private IP address. 192.168, this is private IP address. 192.0, remember this is a public IP address because the private starts with 192.168. 64, this is public. 209, this is public. 192.168, this is private. 172.16, this is private. And then 10.55, this is public. So, so 10.55, this is actually private.